All right, in this video, we're going to look at some more trig equations that incorporate algebraic techniques and trig identities. So the following examples are going to make use of trig identities and some algebraic techniques such as factoring to solve our equations. So example 2a, we're going to solve each of the following in the interval 0 to 2 pi, just like in the last couple examples. So for part A, we have 3 times sine cubed of x equals sine squared of x. Now, this is like having 3y cubed equals y squared in, let's say, another algebra class. And first thing we're going to do is we're not going to divide both sides by sine squared. We're actually going to subtract sine squared from both sides. So we have 3 sine cubed of x minus sine squared of x equals 0. So now we have both terms have a common factor of sine squared, so we can factor that out. So when we factor out a sine squared, we get sine squared x times 3 sine x minus 1. Again, it's like having 3y squared or 3y cubed minus y squared equals 0. You could factor out a y squared, but instead of a y squared, it's a sine squared. So from sine squared x times 3 sine x minus 1 equals 0, we can set each one of these factors equal to 0 and solve. So we have sine squared of x we can have equals 0, and we can have 3 sine x minus 1 equals 0. For our first one, square rooting both sides, we get sine of x is 0. For our next one, we add 1 and divide by 3, we get sine of x is a third. Now, we do have exact values for where sine of x will equal 0. We do not have exact values where sine of x will equal a third. So for our exact values for 0, we get x is 0 and also 180 degrees. Remember, we're not including 360. We're not including 2 pi. For 1/3, if we look at inverse trig, or if we graph y equals sine of x and y equals 1/3, we'll see that they intersect in degrees at about 19.5 degrees and about 160.5 degrees. So 0 and 180 are 0 and pi, respectively. 19.471 here is what we got when we took the inverse sine of 1/3. So this 19.471 degrees as an exact angle is the inverse sine of 1/3, or again, we can still use arc sine 1/3. This 160.529 degrees is taking 180 degrees and subtracting this 19.471 degrees from it. So taking 180 degrees is taking pi radians and subtracting the inverse sine of a third gives us 160.529 degrees, that approximation, as an exact value of pi minus the arc sine of 1/3, or 180 degrees minus this 19.471 to get 160.529. Part B, we have secant squared equals tangent of x plus 3. Notice that we have two different trig functions, secant and tangent. And secant's being squared, which means we can look to Pythagorean identities to rewrite secant squared as tangent squared plus 1. Because as we saw with verifying our identities, that tangent squared of an angle plus 1 equals secant squared of that angle. So now we have all in terms of tangent. So let's get this whole thing equal to 0. We can subtract tangent of x from both sides, and we can subtract 3 from both sides. And when we do that, we get tangent squared x minus tangent of x minus 2 equals 0. Believe it or not, this is factorable. We can factor it as the tangent of x minus 2 times the tangent of x plus 1, and that's going to equal 0. So we can set each of these factors equal to 0. We can set the tangent of x minus 2 equal to 0. We can set the tangent of x plus 1 equal to 0. In our first equation, we can add 2 to both sides and get tangent of x equals 2. In our second equation, we can subtract 1 from both sides and get tangent of x equals negative 1. Now, if we look down our chart, we do have values in the tangent column that are negative 1. We do not have values in the tangent column that are 2. So this one, we can use approximations, but we'll have inverse tangent in those answers for tangent of x equals 2. So for the first one, where tangent of x is negative 1, we get x is 135 degrees or 315 degrees. Or we can go directly to their radian equivalent of 3 pi over 4 and 7 pi over 4, respectively. For tangent of x equals 2, if we do the inverse tangent of 2, we'll get our 63.5 degrees If we look at y equals the tangent of x and y equals 2, we'll see that the two graphs intersect at about 63.5 degrees and 243.5 degrees. This 63.5 degrees is the inverse tangent of 2. This 243.5 degrees is 180 degrees plus the 63.5. So 180 degrees plus the inverse tangent of 2 as an exact value is pi plus arctan 2. That's this 243.5 degrees is pi, or 180, plus arctan, or inverse tangent of 2. The 63.5 is an exact value, is the inverse tangent of 2. So again, using arctan for that, but you can use inverse tangent notation as well. 135 degrees is 3 pi over 4. 315 degrees is 7 pi over 4. So again, just using some inverse trig to rewrite some of these other ones in their exact form that we do not have in our tangent column on our chart. All right, so that about does it for this video. Thanks for watching. I'll see you next time.